Awesome to be here. Thanks for coming. Really excited to tell you a little bit about GPU accelerated analytics. So MapD originally stood for Massively Parallel Database. It came out of my research at MIT. So I founded MapD in 2013. And even though I have to play the role of CEO now, one of my favorite things to do is get technical and code. I'll do it on the weekends. I'll do it with kids in my lap. So I was really excited to have the opportunity to present here because it's not the usual presentation format, and I can get a lot more technical than I'm usually able to. So great. So just a little bit of a motivating use case here. MapD is a platform that plays to a lot of verticals. Verizon is one of our biggest customers. In-Q-Tel is a big investor. We have a partnership with the US government. But one of our kind of biggest areas of focus is the financial services sector, particularly hedge funds and investment banks, basically allowing them to get insights from their data so that they can make better trades. Some people call this quantamental trading. Hedge funds and investment banks are gathering data from a multitude of sources now. And some of that is, traditional kind of enterprise data, but a lot of it is social media. Some of it is what would broadly fit under the umbrella of IoT, whether it's sensors and devices, cell phones, data coming off of cars, number of cars in parking lots, footfall traffic, all these things. These funds are basically pulling in and trying to get insight into how companies are going to do and make trades accordingly. And the data is just getting bigger, right? So the point of this slide is that I think, in general, for an average org, data is doubling less than every 3 years or growing at a 40% year-over-year rate, probably for hedge funds who are trying to be ahead of the curve and gather all kinds of newfangled data sets. This is actually growing at a much higher rate. So for your average hedge fund, for example, you might be pulling in data from all kinds of sources. So you'll have all kinds of geospatial data coming off of satellites. You're going to have data, again, coming off of sensors. Advances in machine vision have provided unparalleled new data sets. So one of our partners, Orbital Insights, is generating very, very interesting data coming off of satellite imagery. And then because we have all this processing power, we're actually able to start to not only create this data, but handle it. And I'll talk about where GPUs come in a little bit. So the result is actionable intelligence on a scale previously unimaginable. And the entire planet is in play. So the trucks, basically trucks driving on the road. You can look at shadows and oil tanks to figure out what kind of oil reserves are there at various places in the world. You can look at housing, new housing starts, land use, airplanes, etc. And so today's market participants must use these new data sets. If they do not, it's at their peril, right? So everybody is trading on these new data sets, and if you're not using them, you're going to be left behind. The issue, though, is not storing the data sets. So actually putting them on disk is relatively easy. The price of storage has dropped precipitously. I think they're saying by 2020 you'll be able to buy a terabyte of storage for $8. So people are building these massive data lakes, these Hadoop clusters. Putting on disk is not the issue. The issue is actually doing compute or analytics on this data. So if data is growing at a 40% year-over-year rate, CPU processing power is only growing at 20% year-over-year. And that's probably actually generous. This is if you're basically using everything Intel is throwing at you, all the SIMD instructions. Most people aren't actually seeing this. They're maybe seeing 5 to 10% per year. And so this compute gap is causing people to take all sorts of kind of awkward workarounds, right? So people are downsampling heavily. People are pre-aggregating. And moreover, people are basically scaling out to massive numbers of nodes, to huge clusters of hundreds, if not thousands of nodes, which of course has tremendous costs. And also, a lot of problems just simply don't scale well. So that's where GPUs come in. So GPUs were originally built to render data to a screen, to render video games. So people realized that rendering pixels to a screen was a fundamentally parallelizable problem. And so at some point, about 10 years ago, people realized that you could do all sorts of things with GPUs, not limited to graphics, that their parallel architecture made it amenable to scientific simulations, and increasingly machine learning. You've probably all heard about the field of deep learning, which runs mostly on GPUs. And then finally, analytics. So database, visual analytics, these kinds of things can be heavily parallelizable. So that's where MapD comes in. So you have these GPUs, which are essentially these supercomputers in a box. They have thousands of cores. We actually can run on a server with 8 GPUs, 40,000 cores per node. And the issue, though, is not this hardware. It's actually being able to leverage it. So there's a dearth of software out there that can actually handle all this data. So that's where MapD comes in. So MapD was built from the ground up to leverage this massive parallelism and processing power to run database queries, run SQL queries, analytic SQL queries, up to 100x faster on a equal price, hardware price basis than CPU systems. And because one of the use cases is so often lightning fast visual analytics, we built MapD Immerse, which is our web-based front end, which can not only leverage the speed of our backend, it can leverage something very special about the GPUs, which is their ability to render graphics. So the GPUs obviously have still the native graphics pipeline, even if they no longer have video outs on a lot of server cards. And we can actually use that to visualize data at scale, which I'll demo for you in a minute. All right. So I went through the slides pretty quickly so that I'd have some time to demo here. So I'm just going to do briefly on this demo. This is just to show you the capabilities of the system, and then I'm going to cut to something a little more financial centric. This is 1.2 billion records of New York City taxi data. Nothing here is pre-queried. This is all data in our system. We're actually using, this is an example of the back-end rendering capabilities of the GPUs. There's no way you'd want to send 1 billion points over the wire to the front end. So if I zoom in here, you see everything updates. We can do this because we can basically send queries to our back-end and scan this data and return queries in 20 milliseconds, where it would take other databases tens of seconds, if not minutes. So I zoomed into the airport here. I could brush over this time. You could actually see this area drop off right here in 2014. That's when they knocked down the Pan Am terminal. If we wanted to, we could lasso that. So we have all these geospatial capabilities. So some of our hedge fund customers love doing this. They'll do geospatial things to figure out how many people, how many taxis are going to Macy's versus Nordstrom's, and make trading decisions accordingly. But that was not actually the main demo I wanted to give. I wanted to give a quick demo of another data set from Quandl, one of our partners that provides alternative data sets to the hedge fund space. They basically have a data set. This is about a little over 500 million rows, a relatively small data set for MapD, but sizable for other platforms. Again, I think running on maybe 4 GPUs. Here we're actually looking at credit card transactions. So we have over 500 million receipts. So we can see revenue by order date. And I'm going to show you how simple it is to build a dashboard. And after that, I'm going to actually transition to a Python notebook to get farther into the data. So let's start here. Let's say we wanted to look at the different merchants in the data. Do number of records. I'll make that into a bar chart. So one of the things you'll notice here is that we made MapD exceptionally easy to use. It's not only fast, but it's very easy to use, that basically anybody in the org can use it. So here we can see Amazon's revenue over time. We could look at Walmart. So Walmart had a really good quarter, probably. And I think that was reflected in their stock price. Let's try to get some ground truth data here. So I'm actually going to add order date. I'm going to add merchant. Let's add the title of the product. And let's add the price. So the great thing here is that because we're not rolling up at all, we have a full granular view of the data. A lot of systems you have to roll up or pre-aggregate. Well, here you can actually see the individual items. So if I clicked on Walmart again, you could see all the products that people were buying at Walmart in granular detail. Now let's say we wanted to look at a very specific product. So say I wanted to look at GoPro. So I'm going to search by GoPro, and now we're looking at kind of revenue for GoPro products. And GoPro is a company that gets intense investor scrutiny, largely in part because they haven't always been kind of hitting their quarters. So the first thing you'll notice here is that this is nice, but we have a lot of products in here that are not actually GoPros. This is why it's nice to have this granular view, and then I can see that, okay, this is an accessory. This is $5.99. So I think we could all say that probably real GoPros at least cost $100, right? So I did that, and now we can see that we're looking at basically all GoPros. What if I wanted to do farther analysis here? I'm going to break it down by merchant. And I'll make that into an area chart. And now we can see GoPro by channel over time. We can see Amazon actually dominating it until recently when it's tapered off. Best Buy has actually become their biggest channel, or at least it's on par with Amazon. And what you can see here is a little bit of tepid revenue growth, right? So this current year, yeah, they barely got to what they did last year. So there's not a lot of revenue growth. So what if we wanted to dive into this into detail, right? So what I'm going to use here, I'm switching to a Python notebook, a Jupyter notebook. And what's cool about it is MapD is a full-fledged database behind the scenes, right? We can do this very nice, fast visual analytics. So our hedge fund customers will use this at the front of their data processing pipeline. They can use humans to find anomalies and trends in the data. And then what they might want to do afterwards is transition and actually do data science. So they might pull the data into R. They might pull the data into Python. And we actually have some exciting things coming on our roadmap where we actually be able to push machine learning right into the database because, of course, GPUs are really awesome for running machine learning. So here I can, I can basically connect to the database. I'm going to get a cursor. I'm going to run a query here that's analogous to this query. I'm not going to break it down by merchant. I'm going to basically get the sum of product price or the revenue by date, by month. I'm going to run the SQL query. And so now I have the results. I have a data frame here. And so I can actually look at this as the revenue shown in this data set over time by month. So I can plot it over time. So here you can kind of see a little bit of a downward tick in this revenue. Here's where I'm going to bring in something cool. So Facebook has just recently open sourced a tool called Profit, which allows you to do time series forecasting. And it uses some very nice Bayesian techniques to do that. So I'm going to make a model. I'm going to fit it and try to predict the future. And so here is Profit's model for future GoPro revenue based on this data set. So if you actually look at it, it's not looking too promising here, right? We're actually kind of showing a downward trend. So people may want to see if this is already priced into the GoPro security, or if not, short it accordingly. Sorry. It's pretty blunt. I'm just from Silicon Valley. This is all. Does that sound bad? They should relook at their models. Let's put it that way. Great. So now we're looking at, I'm going to actually create a new data frame, which actually has deltas both in the price. I'm not going to go too much into this, but basically I'm going to have a delta variable which shows that how much our prediction was off. So one of the interesting things we might do is say, hey, let's look and see if there's a relationship between deltas and what the revenue actually was as predicted by this Quandl data set and what the Facebook model predicted. And anytime there was, anytime we see that revenue is significantly above or below the predicted value, that might be something that we could trade on, right? Because of course the GoPro revenue is going to spike at Christmas. There's a very strong seasonal components, but as you saw above, the profit model is able to take those into account, so it already kind of predicts that. So what I'm doing here is I'm basically backwards predicting, going through the data, trying to predict what the profit model would say the revenue would be and what it actually was, and looking at the delta there and looking if there's any relationships between the deltas and the stock price. So I actually just pulled from Yahoo, and this is very armchair financial analytics. Please don't take this as investment advice. I run a startup. I'm not a hedge fund trader. So I took GoPro's stock price, basically added it to the data frame here, and then you can do a scatter here. And then I made some basically lag variables where I want to see, is there anything about the delta, GoPro overperforming or underperforming the predicted values in terms of their Quandl predicted revenue, and how does that relate to lagged future variables of the price variable. So you can see here, there's not a huge relationship, but I do one lag, so 1 month lag, 2 month lag, and 3 month lag. So this is delta in the Quandl revenue versus 3 month future change in price. So it looks like there's something a little interesting here. I did some quick linear regressions. I won't dive into it. Nothing significant at the 1 or 2 month level, but by the time you get to the 3 month level here, you actually have a R squared of 0.13. you have a t-score of 1.894, so it's saying there's a positive correlation between the deltas in Quandl and the deltas in the 3-month future deltas in the price. So there could be something predictive about this Quandl data. I mean, it's a weak correlation, but as you probably all know, in financial services or in investment space, there's really strong, really rarely strong correlations. You're trading on the exhaust here. So you can see here, and you might actually dive into this data and do a lot more sophisticated analysis than I'm doing. But the nice thing is that with MapD, you have the tools to do this kind of end-to-end analysis. Everything from putting it in, running the SQL queries, doing the visual analytics at scale, and then finally pulling the data out and doing regular data science. So it makes something our clients get really excited about because I'll just give one quote from an anonymous hedge fund that's a big customer of ours. They were saying before we were using 100 nodes of Impala, now we're using a single node of MapD, and it's basically many times faster than that 100 node Impala cluster. It costs a lot less, and now for the first time we really have interactive kind of analytics at scale. Our analysts love it because they can kind of test and iterate on hypotheses in real time, and then they can basically pull it out and do their normal Python and R stuff at the end of the pipeline. So I think my time's up, so I'll turn it over for questions. How do you push data to MapD? Can you use an existing MySQL database as a data store? Yeah, I'm going to actually quickly pull up. So MapD supports all the standard database connectivity. We're typically not your store of record, right? We're normally an accelerator on top of your existing data store, although some people do use this as a data store. You can see here that via JDBC, we can pull in from all your existing databases and data warehouses. And we actually have a very nice SQL connector where you can just point at a database, run a query, and pull the data into the system. No question, but just wanted to tell you that your demos are freaking cool. Oh, awesome. Thank you. Can you give us a couple more examples of MapD's application in the financial space? I kind of covered the hedge fund angle here. There's one other application that comes up heavily, which is fraud detection, which we're just starting to explore with a large bank. So there, the application is actually doing programmatic queries at scale, looking at credit card transactions that come in and seeing if they're anomalous based on both a user's past behavior and a cohort's past behavior. And again, you probably know that there's like a 50 millisecond window to do this. So the idea is using MapD to do these kind of anomaly detections very fast. So that'd be another use case. Can you give us an idea of the speed of integration and onboarding? Yeah, it's great because MapD is SQL, and even though we're using these GPUs to accelerate it, that's totally transparent to the user. We actually cache the data behind the scenes for the user on the GPU. You don't even know you're using a GPU database. Installing the system is just getting a binary. It's just a binary that you install. We also are on Amazon AWS and about to be on Google Cloud, so you can just spin us up on an hourly basis there. Oh, I'm out. Okay, I'll try to answer some of these later on Twitter or something. Yeah. Thanks, everyone.